Well, welcome to this session. My name is Niraj Kumar. I'm an enterprise solutions architect at Amazon Web Services in the UK. I'm also pleased to say we have a guest speaker today from one of our retail customers, Amazon.com. So Bart Schoenershans, who will join the presentation later. In terms of the agenda and in terms of what to expect from this session, so firstly, the first half of this is going to be around a bit of a primer and a high-level overview of AWS IoT and Greengrass, and also give you a bit of a context around IoT and what IoT really means for retail organizations. What are the opportunities that IoT can bring to the retail organizations, which I assume some of you work in. And then second half of this presentation, when Bart comes over, he's going to give you a much more deeper dive to the fulfillment solution that Amazon.com uses, built on technologies like AWS IoT and some other AWS services to really demonstrate how Amazon.com actually uses these and operates at the kind of scale they do. So that'll be more deeper dive the remaining half of this session. Now it's a 300-level session, so we do assume you have some basic familiarity with AWS or IoT, although I'll cover IoT at a high level for those of you who haven't had a chance to look at what the service is and what it can do. So we'll touch upon that. So let's get started. So before we go into the service itself and look at what are the high-level components of AWS IoT and what does Greengrass bring on the table, let's just try to understand first, because it's recognized as one of the mega trends. What does it exactly mean? Now, IoT, when you try and demystify and really try to go beyond the hype and the excitement that always happens with new technologies, it really comes down to having an ability to connect the physical world with the digital world. And by doing so, giving organizations an ability to reason and to bring insight and intelligence from the physical assets, much like what we can do with digital assets. Now, with digital assets, it's relatively simpler because everything gets captured in digital format. You can store that in databases. You can do data mining, machine learning, etc. The IoT is essentially trying to do the same thing, but bring that intelligence, bring the state of physical assets, and convert that into digital world. So that's, I think, one of the key value propositions of IoT. And we are seeing this happening across different industries, from smart homes to smart factories, smart cities, connected cars, etc., and of course retail. And retail is going to be the focus of this session to explore what are some of these opportunities that can happen in retail sector. Now, before we look into some of these opportunities, it's probably worth looking at what are the key trends which is driving the cloud adoption in the first place in retail organizations. And for those of you who are working in retail organizations, you can recognize some of these. So the first one is really around omni-channel. So omni-channel really the solutions that unify, whether it's the physical store, e-commerce, mobile, social commerce, and create a unified solution for the users, for the customers, and give them a personalized experience. The next one, which is also happening, is big data. Now, what's happening is as customers use multiple channels, can often also lead to having this information about customers in silos, in line of business and system of record solutions. And big data is really trying to simplify this from a customer single point of view and from a customer centricity point of view by helping you and enabling you to build something like a data lake, for example, where you can bring all this data from different systems into cloud, store it with all the security, the cost optimization. So cloud is becoming kind of a natural place where you can use on-demand compute to then drive insight and intelligence from customer data. Another thing which is also happening is the digital customer engagement. Now, this is really about where retailers are investing in capabilities like digital signage, in physical stores as well, implementing augmented reality, virtual reality to create that awesome experience for customers, to increase the engagement levels. And now when we look at IoT, again, there are different, if we look at retail value chain from the shop fronts to the front end of where customers come and purchase products to all the way back into the supply chain, the warehouses, et cetera, IoT opportunities are across the value chain. From in-home experience perspective, now we have seen over the years, mobile has become one of the channels that customers use to engage with retail organizations, use it to order products and services. We're also seeing some of these emerging channels like, I don't know if you've seen or played with AWS IoT buttons. In fact, I happen to have one in my pocket here. A simple device which, again, it comes down to simplification and customer experience. With single click or double click, it's a programmable button. Your customers can actually very seamlessly order the products and services. So this is becoming another way of customer engaging with retail organizations. Another one is Amazon Echo. And we are now moving, if you look at the trend in computing, we are now becoming moving from green screens to web interfaces, mobile interfaces, and now we are entering an era where we just want to have conversation with machines. So a lot of customers are now building Alexa skills or using Amazon Lex, which is really the same technology which powers Amazon Echo. So customers are using all different manner of channels now to engage with retail organizations. If you move further back into the supply chain, or even other channels like in-shop experience, IoT, as I said earlier, it's about connecting physical world to the digital world. So if you think about the experience in physical retail shops, IoT can actually help bridge that gap. Some examples being customer come into a physical store. If you have IoT devices and sensors, you can actually bring similar kind of insight that you can get from your e-commerce websites. How many customers came in? How many customers bought? How many customers didn't buy anything? Which part of shop did they actually spend most time in? Something that we can do with the clickstream analysis and all the good things that we get from e-commerce channels. So IoT can really help bridge some of those gaps in the physical and the digital stores. And further back into the value chain, if you look at things like fleet management, things like connected appliances, and when you combine other emerging technologies like AI and machine learning, you can actually try and do some not just real-time analytics, but predictive analytics on, well, how's the fleet behaving? Is there any chance of any vehicle in the fleet going out of action for some time? By predictively analyzing the machines in the warehouses or fleet, you can actually minimize the downtime of these equipments. And that directly contributes to increased customer satisfaction. So it all connects to the customer satisfaction, essentially. Warehouses and fulfillment centers is another one. Now, I won't talk too much about that because that's the core theme of Bart's presentation, to talk to you how IoT is helping Amazon.com really build the next generation fulfillment center. So we'll see some concrete and practical example of how IoT and other AWS services are working in action there. Now, connecting devices, IoT devices to cloud requires undifferentiated heavy lifting. You have to think about protocols. Often IoT devices can speak with different protocols. MQTT, it could be Bluetooth, it could be Zigbee, and many other local protocols that devices may use. You have to think about scalability. You may start with 100 devices to experiment with something, but how do you scale quickly to 100,000 or even millions of devices? Security, really, really important. How do you ensure you can have these devices securely connect to the cloud, and also the security of these devices itself? So very, very important consideration there. And often IoT devices is not just unidirectional. It's not just sending telemetry, which you can analyze in the cloud. You also want to be able to talk back to these devices, control these devices through actuators, change the state of these devices. So it's a bi-directional communication between cloud and IoT devices. And to help build these applications, you need SDKs. You need to make developers' life easier by providing them tools that help them develop these applications quicker and securely. So with these challenges, 2 years ago, when our customers were telling us these are the typical challenges in IoT, is why we launched AWS Platform back in 2015. So AWS Platform, IoT Platform, it's a managed service. By managed, we mean you don't have to worry about any installation. You don't have to pre-provision any infrastructure. It scales automatically, whether you connect 100 or 100,000 devices, and it's highly available. It's redundant across availability zones in a given region. And you pay as you go. In fact, last week we announced some updates to the pricing where it's even more simplified, again, based on the feedback we got from customers. So just very briefly talk about some of the key components here in the platform itself. So starting from the left, we have devices. And we provide you device SDKs in Node.js, Python, C, et cetera, which you can use to develop and write the logic in the device itself. And then it communicates over MQTT, sends messages securely to AWS IoT platform. From a security perspective, we support what's called as a mutual authentication. So there's a pair of private and public keys on both device as well as IoT platforms, so both can actually trust each other. And you can generate these keys either from AWS IoT platform, or you can bring your own keys as well. And then there's a device gateway. Device gateway is responsible for the orchestration of messages either between devices or device and the application when applications want to communicate to the devices. So it does that job of an orchestration. We have something called device shadow. Now, device shadow is kind of a virtual representation of device in the cloud. And that's how a device can report its state. And that's how applications and other devices can communicate with a given device in an asynchronous way. So this ensures that, and which can happen in some cases, in some use cases, where IoT devices may not necessarily be always connected. How do you communicate to those devices? So using this device shadow components is essentially for state management of device. And then there's also rule engine. Rule engine, once you get all this telemetry, all the data from IoT devices, rule engine help you transform this data, filter the data, and also connect to other AWS services. So for example, if it's some kind of temperature sensor, you can filter that data, where temperature is only greater than a particular number, like 20 degrees or whatever. And then you can actually send that incoming telemetry into, it could be Lambda function, where you can do some further processing. It could be a DynamoDB table, S3, and many other services, Kinesis, et cetera, that you can send that telemetry for downstream processing and doing some analytics on top. Also the device registry, which is, think of this as a list or a catalog of all your devices out in the field. So just very final thing I want to talk about before I hand over to Bart is AWS Greengrass, which is an additional, another service we have within IoT services, which was released a few months ago. Now, Greengrass is effectively, there's some use cases where it's not always possible to be connected to the cloud, especially when you have use cases where you need to make decisions in the local device network within a fraction of a second. In some cases, you may not have a very good connectivity or very intermittent connectivity to support those kind of use cases. So there could be law of physics, the latency between your device network in the field and cloud. It could be law of economics. It may not make financial or economical sense to send every single data packet in cloud. Maybe you want to send the data which really makes sense to send to the cloud, so you can do some analytics on top, so you can write machine learning algorithms, do some predictive analytics. But then some data you only want to use to make some local decisions. Maybe something is wrong with the device, and you want to take that action right there in your local device network. And in some use cases, you may also have some regulatory requirements. So when we think of IT, the kind of three pillars, we've talked about the things. These are the actual physical hardware, the sensors, actuators, devices in the field. In the middle, we have cloud, and we've I just showed you the components within the AWS IoT cloud. And then finally, what you want to do with that incoming telemetry. You want to drive some intelligence. You want to probably do some machine learning to do predictive analytics on these machines. Now, with Greengrass, all the components that we see here for IoT in the cloud, essentially, we have packaged it together in a software binary, which you can then take and deploy in your local device network. So Greengrass is essentially a software that you deploy on your IoT devices. It will give you a local device gateway, a local device state, or the shadow, local security, works exactly how it works on the cloud side, and then also ability to sync with the cloud, whatever frequency you want to do, or whatever the requirements for your use cases. And also an ability to run Lambda functions as well on the local device network. This is where all the actions can happen. This is where you can make decisions and control your devices. So some distinct benefits you get with Greengrass, and one already spoken about, the ability to respond quickly to the local devices and local events. And also, because you're not dependent on a dedicated connectivity with the cloud, these machines can operate even when you're offline. The third is around simplified device programming. Because now what you can do is you can write a Lambda function in cloud, you can test in the cloud, and using Greengrass deployment features, you can actually deploy then on your devices, your Edge IoT devices. And once you run these Lambda functions on the device itself, you can do some other advanced techniques like you can apply some sort of batching. You can compress that data, which means essentially you can reduce the amount of data that's going into the cloud, which can directly reduce the cost of your IoT applications. So with that said, I would now like to hand over to Bart and take you through how they're doing this in Amazon Fulfillment. Over to you, Bart.
Thank you very much, Neeraj. So let me take some time. Let me introduce myself. I'm Bart Schouwenaars-Harms. I manage the European control engineering team for Amazon Fulfillment. So we look after automation in our fulfillment centers in Europe. What I'm going to show you now is a short video of our fulfillment network in the UK to give you an idea of what it is that we're doing there. So as you can see from the video, my scope is very hardware orientated. We look after the parcels and how stuff is stored within our facilities. So Amazon Logistics, Amazon Fulfillment. I'm not going to talk about Amazon.com, so the website where you buy stuff, or AWS itself. I'm going to talk about what it is that we use from AWS and in which applications are we using it. So there's a couple of topics within my talk. I want to talk about the fulfillment center design, what we're deploying at the moment. Including in that is also the equipment design and what we've talked about, or what we've designed as machine as a service. Then the AWS technologies that we use, and also I want to give you a bit of a look at what are we brewing at the moment in our lab, what are we going to be deploying in future years. So the existing designs that we had within Amazon Fulfillment is the basic triangle for control engineering. We've got our sensors, actuators at the bottom, the machine. The designs that we got from our system integrators, they're very rigid, very monolithic designs, so not a lot of flexibility for us. Then our warehouse control services are local servers based in our fulfillment centers, and the warehouse management service on top is usually rack mounted in our data centers. The newer design that we're looking at is using a lot of modular design at the bottom. So we want to create our machinery as commodities. We want to be able to go out to the market, talk to any machine vendor and say, this is the functionality that I expect of a machine. That's what I want to buy. And I want to buy it 20, 30, 40 times and just deliver me that identical copy. The local servers, still there, but now we're moving towards Greengrass and the warehouse management services running in AWS. So from a system integrator's point of view, we used to be users. We used to be just buying their equipment the way that they designed it. What we're moving towards is we wanted to be a development partner. We wanted to be working with them to create equipment that followed our designs, that followed what we wanted to get out of them, not just what they were willing to sell us. The international standards that we started using, it's ISA S88, and even though it's a batch control standard, it applies to discrete manufacturing and also continuous manufacturing. So for us, we try to build our tree starting from the enterprise, so Amazon customer fulfillment, working down to site, area, process cell, and we wanted to be able to integrate with the process cells, and then also the units. So for us, a process cell is defined as a machine, and the unit is usually the smart equipment that we get. We get sensors, glue systems. They're just a single part of a larger machine. So if we then take that modular design and look at how do we design a fulfillment center, this is a simple block diagram. And starting at the top, we've got receive routers, then Amazon Robotics levels where we store our equipment. Then it's picked, so it goes to a router as well. But where it starts getting interesting is the levels below that. The red blocks that we've marked are the unique typicals that we created. So if we've got one of those, the white ones are just purely copy-paste. So if we get our singles line, for instance, if you look at the left, there's one red block. That's what we design, and then we copy it 7 times for this fulfillment center. If we need higher capacity or lower capacity in a certain region, we just build 4 or 17 of those lines within the fulfillment center, but exactly copy-paste. So we design it once, we commission it once, and that is then rolled out. So that also means that we need to get a different design for our equipment. We need to start looking at equipment in a different way, because our integrators, they used to do 8 packaging lines on a single PLC or a single controller, and we wanted to do it differently. So we designed it as machine as a service. It's plug and play. If you need 8, you've got 8 machines. If you need 7, you just unplug one and you work with 7. Again, international standards come into play there. It's IEC 61131-3, so programmable logical PCs. Our associates in our fulfillment centers, they're very experienced with PLCs. They know how to manage them. They know how to troubleshoot them. And that's the standard that we would like to continue using there, because that's what they're familiar with. So hardware-wise, established PLCs that we use Siemens, Allen Bradley, Mitsubishi. So geographic locations determine that. So Japan, a lot of Mitsubishi. North America, a lot of Allen Bradley. Europe, well, a mixture of Siemens and Allen Bradley. But then we started looking at soft PLCs as well. That gives us a lot more flexibility, and a soft PLC allows us to integrate more with the Amazon Web Services ecosystem. So Codesys is one of the companies that we work with. They create a very good soft PLC that you can load on almost any type of hardware. Industry 4.0, big for us. We want to extract a lot more data out of our machinery. We want to create that smart factory. So if we need to have capacity, if we need to use machinery, Industry 4.0, those principles allow us to do that. If we want to respond on data changes, if we got in Industry 4.0 compatible machinery, that allows us to do that. So it is big for us to start going in that direction. One of the things that was really noticeable for us, it's not a revolution, it is an evolution. We can go to our integrators and we say, I want you to change your complete design strategy, I want you to create new machinery for us, and they're saying, well, you're only just one customer, why would we do it? So it's small step changes. Every year on year, we start improving the machinery and start improving their processes. So machine as a service, what we define there, it's not exactly IoT or industrial IoT. It takes a lot of the lessons from industrial IoT, but what we need to keep in mind is equipment lifecycle. I've been in the industry quite a while, and I've worked with machines that are older than myself, and they're still in operation. So if we're looking at the equipment lifecycle, it needs to be able to run for at least 30, 40 years from now. Another issue that we've seen is cloud connectivity issue. And the way that we design our equipment is always low-level equipment always works, even though that the higher-level equipment isn't operational. So that could be a SCADA system that's local, or a warehouse control service, or warehouse management service in the cloud. Every piece of equipment at the lower level needs to be able to operate without that higher-level connectivity. So it needs to be able to run. Might be limping. It might be not as efficient as it can be with that cloud connectivity, but it still needs to run. I can't have my fulfillment center standing still if we lose a WAN link. And then what Neeraj mentioned, security, it's a big one. You need to be able to have the security in your installations. It's not just about, am I about to lose data because of security? It is also about, is somebody going to wreck my machinery if they get access to my network? The chosen design that that we move forward with is industrial PC based. It's a Linux based OS with that soft PLC that we mentioned from Codesys. So those are the machines that we're designing in-house. That's the chosen platform for us to use. Then what AWS technologies are we using? And we started using AWS technology about 4.5 years ago. One of the first applications we had was with our SCADA system. We use Ignition from inductive automation, RDS, MySQL database at the back end, so we store all of our historical data there. Usually, historical data was stored on a local server. You had a database that could hold a month or a couple of months worth of data and didn't give you a lot of feedback when you started looking at it. With RDS, we can store a lot more data, and it also gives us the tools to analyze that data a lot easier. Elastic compute, so EC2 instance running that Ignition server. So we moved from our local SCADA into a cloud-based SCADA solution. S3, we want to be able to deploy Ignition to our servers, so the install binaries and a lot of configuration data is stored there. Then container service, EC2 container service. We connect using IoT to machines, and we then virtualize those machines. So if you've got a sorter in your facility, you can create a virtual sorter in the cloud using ECS, and then feed it with live data, but then change your sorting algorithm or change some parameters in it and see how it could have responded on that actual data that you're putting into it. AWS Code Deploy, very good one for us. If we have changes in software for our machinery, because of that soft PLC platform we have, we just push it into Git, the project artifact gets built, the build fleet, and then we deploy automatically to our machines. The thing to keep in mind there is safety. Be very careful that you're still complying with the safety regulations within the area that the machine is. IoT buttons, this is one I like myself. We use it on our machines. So this is a picture of the machine where we put the shipping label on the box. So you can see the label applicators at the side with the parcel underneath it. Those apply the label, then there's a barcode scanner looking down at the box to verify it. But on the machine itself, we've got an IoT button. And if the machine runs out of labels, what used to happen is that the associate turned on the light. Somebody had to spot that light, walk to the associate, say, what can I help you with? They then said, I need labels. Put an IoT button on there. One click, the water spotter gets a notification that we need labels. A longer click, means I need to call an engineer. So the engineers get an automatic message saying that machine needs assistance, it's not running as well. Kinesis, a big one for us as well. We want to analyze a lot more data, what we're getting out of our facilities. So we push those into Kinesis, similar to what streaming data for any other industry would be. Again, the machine that put the shipping label on there, how are we using Kinesis there? Our barcode reader is connected to the PLC, but we've created a parallel track that goes straight into AWS IoT. And with every read, we get the location ID, so that identifies the machine that we're working with. The item ID, what barcode scan has it found on the label, but also we can append units of measure. And that's the more important thing that we're looking at. It's not just about the data, it's about what's happening around it. So the unit of measure might be the weight, the length, the height of the box. You can go as far as, if you've got a radioactivity meter, how many becquerels is it emitting? We don't specify what unit of measure that you can add, just add whatever you want, and there's an identifier for it. That then goes into Kinesis Stream, where we're analyzing what is my read rate for that barcode reader. The barcode reader might be reading 99%, and that's great, but we want to know about that 1% that isn't reading. And because of those units of measure, I can then analyze, is it only reading low boxes? Is it having a failure with the high boxes? If it is a failure for the high boxes, then stop sending high boxes to that machine. With that cloud software basis, we can start making analysis like that, and we can start making decisions based on that. Another point there is we're using a lot of S3, so storage. If we have a no read on the camera, the Lambda function will extract it from the camera, get the image, store it in S3, but also we are pushing the information to Node-RED just for quick dashboarding. Historical data goes into Redshift, and then QuickSight for analysis. A sorter that we use, this is a simple loop sorter, cross-belt. Picture of it, so you've seen it in the video. Parcels go on it and then get diverted to all of the pallet locations where we then can ship them out. The control panel for it, it is quite a complex machine, so it has a lot of functionality, and we want to get a lot more data from that instead of just what the vendor's telling us. Yeah, we sorted the parcel. So one big thing that we've also did is I want to know the energy consumption of all of our machines. So every machine that we've now built includes power measurement. And that gives us a diagram like this where, again, we've got a barcode reader with locations, but it also inserts which induct is it coming from. We've got the motor information, so motor current, motor speed. We've got the power consumption at the top. Vibration sensors are mounted on the machine. So if we have a lot of vibration on there, we can start analyzing it and say how many parcels were on the machine. Were they heavy? Were they light? Is there anything else that we can determine what is the cause of that vibration? How is Greengrass fitting into all of this? If we look at ISA S99 for our diagram, we've got the industrial machinery at the bottom that can communicate with our DMC, the EMZ, so demilitarized zone. Then you've got your corporate zone on top, internet at higher level. The only layers that can communicate with corporate or even internet are the ones right underneath it. And Greengrass fits in our DMZ design. So it sits in our local site. It runs all of that software that you need local. And then using VPC, we're connecting to the Amazon cloud, where you've got all of your high-level software running. One more thing is what's brewing for us at the moment. What are we looking at for the next couple of years? Greengrass on new machines. And we mentioned if you've got a platform running, Greengrass is a light executable. We're working with Siemens, Rockwell, also B&R, that their new PLC platforms, they're actually hypervisors. They're running a soft PLC on their hardware and allow you to run a PC or software-based solution right next to it. So the ET200 open controller from Siemens, we're able to load Greengrass on that. So that is exactly Greengrass on the machine. Allen Bradley, B&R, same principle. They're doing the same things, and we're testing that out as well. If you need to fit Greengrass to your existing machines, a lot of them don't support, or you don't want them to directly connect to the internet or higher level software. You can use a simple device like the Siemens IoT 2020. It's an x86 processor. You can load Greengrass on it. You can write your own applications. and then with either digital I/O, get some connectivity with your PLC, or using the machine protocol, extract it using your network port. The next one is a small video that I want to show you about what we can do.
Alexa, tell pump to turn on.
Turning pump on now.
Alexa, tell pump to turn off.
Turning pump off now.
So this is a little video that was built with our colleagues or our friends from Siemens. We want to be able to walk up to a machine and say, turn on, or run diagnostics. It sounds a bit like Star Trek, but we are trying to move in that way. As an engineer, I just want to walk up to a machine and say, run diagnostics. It's going to tell me I'm running at this percentage of OEE. These were the last 10 faults. Make it a lot easier. If I'm an engineer, head deep into a machine, and I need to inch forward a belt, I want to say, Alexa, inch forward this belt, and it will do it. But again, safety. Keep in mind that you're always adhering to your local safety regulations. In short, that's it. We've got some time left, so if you've got any questions, feel free to ask them.